Hi guys, in this tutorial we are exploring design patterns and with Java implementation. So in this video we're going to focus on the visitor pattern. So what I've done was split patterns across videos. So each video will focus on just one pattern, which will make it easier for you to watch only those tutorials that you're interested, those patterns that you're interested in. So in this tutorial, we're focusing on the visitor pattern, and it applies when you want to perform a certain operation on a collection of objects, but these objects have different types. They may have the same supertype, but their subtypes are different. And it is usually applied when you don't have control over the original source code, or for some reason the classes that you want to operate on, or the objects that you want to operate on, their classes are frozen for development, which means you can't change them, and you want to add new functionality without altering existing code base. That's kind of the use case for this pattern, and also follows the open and closed principle. Right, so we're going to first create an app so we can run it. Here's my shortened project object model, so you don't have to follow the previous tutorial on how to make Java 11 work with JavaFX 11. This is the kind of short version of it. So I'm essentially following the standard boilerplate that I usually create. And that allows us to have a JavaFX program that does something, so we can see it actually works. Let's do with that. The entry point is what we need, and since we're running on 11, we also need the launcher, which does essentially the same. So it just delegates this call to this main. Okay, so that's done. Now we can run the launcher. Make sure not to run the app main, but the launcher main, in which case you'll see this. That is running on Java 11, which means I can do stuff like this, which is cool, compared to Java 8. Right, so the visitor pattern. First of all, let's create a scene, or have some objects on the screen, and then we'll do something with them. Let's go with list of nodes. These are my nodes, and I'm going to create. I don't want to use new API because you might be using Java 8, so I'm going to go with the standard things that existed back then. Right, so we've got a list, and it contains a new circle. Let's go 50, 50, 50. New rectangle. And this rectangle is going to be something like this. What's the problem? How can you not infer the arguments? These are nodes. Oh, fair enough. I don't think there's a constructor that matches this. Fine. Arrays as list. There you go. That existed back then, right? Yeah, cool. New, let's do new line, 20, that's the XY, okay, XY and something like this. So we've got our nodes, and we're going to get children add all nodes. Cool. I also want to reposition the nodes for each node and set translate x math.random multiplied by, say, 300, translate y random 400. Right, let's see what we've got. So we've got some things. We've got a really small line, a big circle, and a medium rectangle. Let's make the line thicker. Right, I can't do that here because I'd have to typecast it back to a line, which I don't want to. Anyway, that's not part of the design pattern. The bit about the design pattern is, say we wanted to recolor each of those nodes to something else. Obviously, we could do it here, but a node class does not have a set fill. All these are shapes, so I could have used shape and kind of got away with that. But still, line is the color of the line is not set via the set fill method, which means it still has to be something different. And imagine you had a different type of node there, which is not shape. So you'd have to still do something like if an instance of something, and whenever you use instance of, that is basically a sign, which typically means you need to redesign your program. So how do we do this? And the answer is the design or the visitor design pattern. So first of all, you create an interface called, say, something visitor. In our case, we're visiting nodes, so might as well call it node visitor. There's going to be a method per the type, one method per type of things you're going to visit. So we have circle, rectangle, and line, and this is where you're going to add circle, rectangle, and line, and any other classes that other types that you're going to, or you want to add new functionality to. So these are classes that come from JavaFX, right? So we can't just take this class and add new code to it, because it's part of the library and we don't have access to it. Right, so we've added those three functions, those three methods, and we're going to implement them. So we're going to add new functionality to existing classes without modifying the existing classes. That's the takeaway message. Let's go with the concrete implementation now. So color changing visitor, which implements node visitor. So this is going to be a static class because we don't want to be non-static implement methods. And if you wanted to have a different, if you want to add different functionality, new but different, then you simply need to implement this interface, and there you go. So for circle, I'm going to change the color of all circles to red. All rectangles are going to be set to blue. And all lines, recall that you can't use set fill, you have to use set stroke. Color, let's go with blue violet. I'm also going to change the width of the stroke, so it's thicker. So you can see that we can, based on the type, call different functions and apply different functionality. So that's done. Now, how do we wire the two things together? So we've got this and we've got that. And the answer is going to be in this static class, which is going to wire these two things together. And I'm calling this visitable node. T node. Let's have T node. We're going to take this as a constructor. we're going to have visit method, which takes that thing. So we're not specifying anything concrete here. We're just referencing this interface, which means you can supply any kind of implemented visitor. And this is where we do the reflection trick. Because currently, if I did this, it won't work, right? Because that is of type T. We don't know what the type is. So what we have to do is get a method from the visitor object that is the right type. So there are three methods called visit, and I'm going to pick the type based on the type of this node. Node get class. I'm assuming this throws a bunch of errors, so I'm just going to do that. Yeah, I'll just leave it there. Method invoke. We're invoking this on the visitor. So remember, it's this object on which we're calling visit. But these parameters or arguments are, well, there's one, which is node. So I'm going to pass a node into the method argument. I'm just going to get rid of that, so we capture the generic exception. And it's just that, these two lines. And that is of type method, by the way, if you're using Java 8. Have I used var anywhere else? Yeah, that's pain. There you go. Right, so we've done that. Finally, we're now going to actually call this stuff. So nodes, well, these are actual nodes. We need visitable node type. So I'm going to do a bit of functional programming, or functional approach, I suppose. Not much, just calling stream and a bunch of other functions. And you can be real cool by calling this functional programming. So we're going to map this to our node visitor. And for each such node visitor, we are going to... Why are you not happy? Oh, it's the visitable node. Sorry. There we go. So we're wrapping the actual node with this our node class that we created so that we're able to call this method. For each such node, we're going to call visit, and we pass the node visitor, which we'll create. So if you wanted to add new functionality, you would implement node visitor and supply a different concrete class just here, which means by just changing one line, you can have different functionality implemented. There we go. Let's try this. Yeah, I think it worked. So we've just changed a property of each objects on the screen based on their types. So for circle, we set its fill to red. With rectangle, we set it to blue. With a line, or that line, we set the stroke width to 4. Let's go 15, so it's even more visible. And we also set its stroke color to blue-violet. And that's the essence of the visitor pattern. So in games, for example, you can have a variety of game objects, such as enemies, player, decorations, power-ups, and you don't want to add or change the existing classes. You want to add new functionality, say death animation for each of those types. Then you just do this. And that's your visitor pattern in a nutshell. Right, so in this tutorial, we've created our visitable class, which wraps existing class types. We created an interface called visitor with those methods, one for each of the types that you want to add functionality to. We've implemented the visitor with concrete class. We altered some things, and we then used the visitor object, which we've created, on the existing class instances. That's a long sentence. So we've had this instantiated. These are obviously different types, although their supertype is the same. And we've mapped those to our wrapper. We've wrapped them with our visitable node. And for each such object, we then visited it, thus added new functionality to existing classes without modifying the classes. Cool. Thanks for watching.